So what is the data transformation? So simply you will say, sir, it is just like the changing or updating the value of a data. You are right, but we have to say we have to change in terms with the help of some. We cannot change the data. Like if there is a suppose this is a suppose this data. If I will just like anything, I can put like a 20, 26. No, it is not good, right? We cannot change the data like voluntary by our choice. Okay, never to do it. Okay, so we have to use some mathematically functions. Based on the mathematically functions or mathematical equations, we have to update the value of the data, right? In that case, that is called the, this is a process or technique by which we can easily change the value of the data based on some mathematical equation, right? So next, which is most important to understand, based on that equation, each value in the data set should be changed. Think about it here. So suppose this is the suppose variable day 1, day 2, day 3. Just think. So actually I will tell you what is this data. So day 1 data. So suppose this is the day 1 data. So if I want to apply mathematical equation, it should be applied to the whole variable, right? Not on the single value, which is most important. I need to change not in the this or this or this. No, not this record. I have to change the all variable value, right? Similarly, second and third, it is your choice. So basically, this is the data transformation. We have to change. So this is the small equation or general equation. So what will be the new value? That is like a y. New value of the data value y. Y is a variable. I is somewhere is the value inside the data somewhere. And the function that is the some mathematically functions. We will learn these functions now. F of that old value of the data, old variable, and this is the ith value. So my students, data transformation concept is clear to you. Now you will say, sir, why we need the data? This is a question. Data transformation, right? Because I told you some statistical test has some assumptions. Do you think normality, homogeneity, and another maybe can linearity and some more? Okay, so as we just learned about these two type of a assumptions based on the test, right? In a t-test, you know, we have some these rules. If your data is not have that rule, not conforming or not touching that rule or not fulfilling that rule, in that case, what is the answer? The answer is maybe you have to drop that technique. You have to choose the non-parametric test. Previously I told you, right? Other option is you can correct your data. You can transform your data, right? So then your data can be normal. Mostly the data analyst use this technique for the make your data normal distributions, to make the data normal distributions, right? So transformation method. So please try to think about it. We have some transformation method. First one is, my students, reflective transformation. But before it, please try to understand. Do you remember we have some skewness? Do you remember I discussed with the some positive skew or negative skew? So that should be clear to you. So positive skew data, whenever your tail of data is going to the positive side, right? Negative skew data when the tail is going to be the negative sides, the slope. You
Can you see
understand?
here?
So this is the tail. If going into the negative side, it means to say negative skew data. If the tail is going to the right side, then is a positive skew data. Do you understand? So we discuss, I think, the some last session, and you know very well. Okay, so first of all, we have to see this type of a curve of our data, and we can easily see is it a negative type of a or a positive type of a, right? And also you can check the value in the tables. Okay, so based on that skewness, we have to apply the transformation. This is the rule actually, right? So first of all, reflective. So what is the reflective? So we have to reverse for do the reverse. Actually, reflective mean to say reverse the value of the variable. Okay, for the negative skew data. If your data is a negative skewed, in that case, apply reflective transformation, right? And how we can apply, find a maximum value in the series and add 1 plus 1 and minus the variable. So this is the formula to apply the reverse transformation. It is a reverse transformation. Sometime in a books you can see the reflective transformation, in which case if your data is the negative skew data, right? So second one is the log transformation. Do you know about the mathematical functions log 10? So we have to do log x. So we have to pass the variable value log x. For which type of a skewness? If you found a positive skewness in your data, this is a log. Third one is a square root. Okay, so you can also use for a square root transformation for positive skewness. So the last one is a reciprocal. You can also go for a reciprocal. Reciprocal mean to say that like a opposite. If you will divide the variable value by 1 by x, in that case we can see that is a reciprocal. So this is again a positive for the skewness. So practically I can say if I have a positive skewness of a data, please apply these three type of a transformation. If your data has a negative skew value, in that case you can apply reflective, right? And after reflective, you can, if you, because there will be new variable, reflective variable, and you can also apply that one after reflective. But you have to test which transformation is good for your data, which is important, right? So that's it. This is a formula. Now, how to test a skewness? I told you in the last some lessons we can check it. So let's try to check our skewness here. Okay. Okay, so we have to go to the analyze. Please do with me and go for descriptive statistics and go for some explore. Okay, okay, explore and first of all, I think I have to discuss the data once again, which is important here. Just a moment here. So actually, this data is, I want to open the case study, data transformation, and I have this file, I think, this one, national seminar. Just think, I want to open once again in front of you. So then we can understand the file. So basically there was some university, sorry, not a university, here, national seminar. Yes, so there was some seminar like a conference held on some topic like a digital India somewhere in I don't know which place or somewhere. So actually, there are a lot of participants, around 800 participants took part, right? So the question is, basically, each participant was asked or measured on the day about what was the hygienic status in that conference or event, right? So first day, what was the status of, there was a very hygiene environment or not? Second day, what was the position? And third day, what was the position of hygiene, right? Okay, so they given the response like a poor to good or very good or maybe excellent, from 0 to 4 likewise. Okay, there are a 4 type of a scale. So now we want to know, actually you can also apply any other test if you want to do, but we are not focusing now on any task or hypothesis. Just I'm correcting the data. I want to correct the data based on it, but I want to tell you what is the actually data, so you should understand this data. Okay, so this is the actually data. So now can you see the day one score? This is the mean value, like average value of the target. This is the categorical variable, like a male or female, because obviously male and female took participated in that big event, and male given that report, mean to say this male is asking that first day condition is very good, like excellent, around excellent, very good, 3. Okay, and day second, uh, hygiene condition is going go down. They said in second day there was not a good hygiene condition. Okay, mean to say there is no good cleaning or something like that. and the last day of the closing something, so very bad, they didn't find a excellent condition. Just think what are their opinion and something. So these are the just I discussed for the one record, one person. Similarly for the all, you can easily check it. Okay, so can you see this data have some missing value we have as well as, because this record or maybe uh, these record easily filled, but they maybe they forgot it, they don't want to fill, we don't know, right? They didn't fill that data, right? Similarly like that one. So this is a missing value, and you know very well we can also handle the missing value. I discussed with you in the some sessions, so you know very well. But the topic is to be correcting the data, to transform the data, right? So let's see for analysis and descriptive statistics and explore. You can check the data for day one. Let's for day one and day two, right? Day one and day two. Take this data to the dependent list, right? So dependent list mean to say the test variable. Just think. And if you want to check for the each category, you can go for the gender, put in the factor list. But I think now I will no go for the in detail. You can take here in the factor list if you want to check category wise normality checking like. Okay, so now statistics, no. Plot, okay, which where I should click on it? Normality plot, or obviously you can use histogram as you want. Okay, but it is your choice. Okay, so let's see what is the output coming into my system. Please do like that and check the status of the first day or second day. Okay, so we will see which is good for us and where we can apply the output in front of you like that. Check it first. So test of normality. This is the hygiene condition for day number first. Oh, great. From the histogram, I can see it is looks a very good data. So there is a bell type of a curve can you can make it. It is not exact the it's not a pure normal data, but 80% it looks okay, right? Can you see there is any tail or left or right side? I think I cannot see here. So in that case, I can see that it is likely to be near to the normal distribution. Which data? For the day one data, right? So you can also check from the test of normality. Yes, it is good. Can you see this significant value? It is insignificant seems, because value is greater than 0.05. If it is greater than, it means to say the data is normal. Data touch the normal distribution. Which day data? This variable, right? Now, can you find the second day data? Oh, it is less than 0.05, right? It is already less than. It means to say it is significant. If it is significant, it means to say it is not a normal data. So we have to work for this variable. Okay, we have to correct this variable value. We have to transform this variable value. We have to improve the data, right? So in that case, we have to work. So for variable number one, not important now because it is already normal looking. Okay, you can work with that data, no problem. But I want to correct that second variable. Okay, so first of all, how to test skewness, I discussed with you, and this steps you have to follow, and then you can see the result over here. So I put, let's see the skewness first. So this is looking okay. I put here, and this is like for me it's a positive sides, positive skewness. So I want to focus on that one, right? So now the question is, let's apply the log 10 first, right? Okay, let's apply for the log 10 first. So where we have to go first of all, transform. There is a button. You can see the option transform. In transform, you have to make a new variable. Click on the compute variable, right? So here you can write the new variable name. So suppose log 10. So I will give the name log underscore day 2. Why day 2? Because for the learning purpose, for the memorizing, that I'm correcting the day 2 data, right? So try label, you can set the label like that here. Okay, now here Go for the arithmetical options in the functional group. We have a lot of functions. Where is the log? Can you see the log? Log 10 you have to select. Okay. Can you see the log 10? So you have to pass the value of that variable. So our target variable is day 2. You can double click on it or you can take there. So now day 2 is there. Now one important thing is uh, you have to do a +1. +1. Why +1? Because in mathematically log 0 mean to say infinite, so which is not good. Log 1 value is a 0, because in my data if there is some 0 value then it can be infinite. It is not good. Then I need to make the transformation with adding +1. Okay, so that's why I added 1. Solution, I want to make that variable based on this value. So these are some operators you can use, plus, minus, whatever, but I use my own keyboard, so there is no need. So let's go to the click on the OK. Okay, and immediately it should create a new variable here. Can you see here? The new transformed variable is in front of me. The old variable is day 2, new variable is log day 2. Right now my task is to be check whether it some improvement or not, because the data was day 2 of the positive skew, so it is reduced or not. Okay, I want to check. So let's see, I can make a graph here. Graph chart builder, and histogram is a very fast method. You can very easily check it. So where is the histogram? Here. You have a lot of, do you remember one day we saw how to make a chart? So you can select simple histogram here, and this is the my new variable. I can take it into the x-axis easily, and histogram will be, you can take the percentage, but mostly we can use the histogram value here. Okay, let's see what is the graph can tell me now. So now it was the previous graph, old graph. Now it is creating a new graph for me. Let's see. The previous graph was for day 2 here, right? And I put here in the looking positive skew. Now, what is my new graph? Can you see? So my data is reduce the positive skewness. Now it is not going more on the positive side. Can you see? The tail is reduced. Can you see? So it means to say it is not exact the normal distribution, but I think this transformation works good as compared to the one. So I put here. So I can say the reduce the positive skewness with the log transformation, log 10 technique. So you will say, sir, it is very simple and very easy to use. Compute variable. Again for the compute variable. So what is our next transformation? Let's go for, I think you see the result of log. Now let's go for the square root, right? So square root, we have to give a again new variable name like a Sqrt. Okay, for the day 2. Okay, one more thing, you have to do a reset. You can do reset again, Sqrt and underscore day second. Okay, now go for again arithmetical. You can directly type here, or maybe you can find here square root. Can you see the square root here? I can click on it. Now square root function is again calling. I have to pass the variable value. Which variable value? Day second. But please see day second. Here we have no problem because we are going to square root. So no need to do plus add or one. There is no concept of infinity or something like that. So take a day 2 variable. Very simple. Click on the OK, and immediately you will see the new variable is in front of us. This is again a new variable, right? So it is also created over here. So now can you check again with the graph chart builder, and let's check one by one everything. So we have to check it again, reset it, and square root I take into the x variable, x axis. I think it is a little bit improvement, but let's see, maybe it is improved or not. So it was the log transformation, but I want to show you the new graph. Yes, now it is more improvement. So see how I can improve the data from the initial stage up using the log, and again square root transformation is also good for me, right? So which I put here in the chat, in the slide. So it was the original. You see from where we have started. Original log 10 works good for us, but it is not good. So then I applied the square root, right? So square root made it good for me, right? So this is a good transformation. So
No
please.
problem.
Last is the inverse transformation. Yes, inverse transformation you can also apply. Let's see. But I want to check maybe my data can be more effective or not. But you can use transform variable, then do reset. Here you can see inverse. This is the last transformation, inverse, and day 2, just for memorizing. And okay, so how we can do inverse? So inverse is like a 1 divided by, you start a bracket here, give a value of day 2. Okay, one more thing. So because if the variable value is 0, so in that case, if I will divide it something with the 0, it means to say infinite, so which is not good. So in that case we have to add 1 once again, right? So now what I can do, I can easily create a inverse type of a transformation variable. So I want to check everything. Inverse day 2 is again created for me. Now I want to again make a graph for that variable, because graph is a good, so we can easily have a good idea, good guess that we did something and we achieved or not. Inverse I can take over once again here, and I can apply that one. Now I want to see again a new graph is in front of me or not. Yes, it is again looking a good, but in this data sample and using this technique, I found the conclusion is secure root is a very good. Square root is a good looking transformation for this data only. Okay, so in this slide you can see inverse, because previously I show you this was the starting data which was not good, but square root improved it. But now if I want to compare all three transformation, you can easily see the result. You can see, sir, this square root is looking good as compared to the log or inverse, but sometime this can be very good for the data. It depends upon again the data. Please try to understand. Sometime it can be good or sometime it can be good, but mostly I found, as per my experience in my personal data, when I use in research or something, so in that case square root gives a very good result. So this is good one, you can use it. Okay, now let's test all the transformation. Let's test all the transformation. You know very well how we can test all the transformation very easily. Go for the some statistical test. I told you with that graph, there is no conclusion we have to say. There is no conclusion we cannot say, because there is some improvement we can see from the diagram, but actually it is not a real normal distribution data, not exact. So how we can check it with the some test? Which test I show you previously? So analyze, descri- uh, descriptive, and explore. You can see here. So now go back here, and what was the initial data is here, initial variable, log, square root, and inverse. So these three transformation we did it. Let's see. So I put in the dependent list. So factor list, it is not important now, for the category if you want. So plot, normality I can check. Histogram we already made, but no need to make now. Okay, so let's see what is the output now comes in front of us. So this is the same output which I show you on the PPT. Let's see what it will do for us. Yes, I think I received some result. Can you see this normality value? Here, the original data was poor. If I apply the log transformation here, it is didn't work good, because the p-value is again less than. But when I apply the square root transformation, data is improved. It is going to near to the zero p-value, like it is near to the 0.05. Maybe if we improve more missing value and we can put some mean or median or something, then it can be again improve. Please think, It can be maybe 0.6, 0.7, 0.8. If it is 0.6, it means to say you can perfectly use that data, right? Inverse transformation, no, it is not good. So skewed transformation gives a good p-value here as compared to the others, right? So I put here in the next slide here. So conclusion for from this data sample and this session, scare root seems effective, but still data is not normal because I found according to the test, p-value is again a less than that one. It should be is greater than, right? It is significant. It should be insignificant, right? So if I'm going to conclude, so we in this session did a definition, a reason to apply, why we use it, and we apply a reflective, log 10, inverse, or square root transformation, right? So if I found a negative skew data, I have to apply the which transformation? The reverse transformation. That is a reflective transformation. You can apply, right? So thank you very much. It was for the whole today session, which I wanted to convey to you about the topic.